last topic of dealing with a polynomial and a quadratic specifically, because obviously if a quadratic or the polynomial is not a quadratic, then obviously there's a different route to go. So we know it's a quadratic because it is in the format where there is an x squared term as the leading coefficient. Typically, we're going to look at quadratics that are polynomial, trinomials, so 3 terms along with that leading coefficient of x squared. But then we'll look into some that are a binomial and so on and so forth. So in any event, there are 2 methods to solve. The first one is kind of written out here. And we do that by factoring. So the first thing that must happen is the quadratic is set equal to 0. So as an example problem, let's say we had 7x squared plus 12x, and we're going to say that that is equal to 27. Well, obviously that is not set equal to 0. So to make it equal to 0, we need to move the 27 from the right side to the left. Now, sometimes the polynomial is already set equal to 0. In this case, to move the 27 from the right to the left, we do the opposite, so we subtract it. So now we have our quadratic equation set equal to 0. So the second step, so this is done. So the second step is to factor it. So we go about factoring however we want. So I already have this kind of worked out, but just to kind of show you in the context of it, using the box method, 7x squared would go in the top, negative 27 in the lower right. 27 times 7 is a negative 89x squared, but we need those to multiply and then add to get 12x. So again, working through our factors of negative 189, which would be a 17 and a 17, those don't work because that makes 0. If you did 17 minus 17, we need a 12, so it winds up being 21 and 9, but the 21 has to be a positive and the 9 has to be a negative because that would multiply to be negative 189, and then they would add or combine to make positive 12. So 21x and negative 9x. So now as we factor our common factor, across the top is a 7x, across the bottom is a negative 9. The left column is an x, the right column is a 3. So our factors are 7x minus 9 and x plus 3. So if the problem factors, all right, we still have that set equal to 0. So now we use something called the zero product property. And what that means, if you have 2 values that are multiplied to equal 0, so if we just kind of, just as a side note, if A times B equals 0, then either A has to be 0 or B has to be 0. Okay. If we had x times y times z that's equal to 0, well then either x or y or z or a combination of them, but at least one of them has to be 0. Because if x, y, and z, or a and b, if those were numbers or fractions that are not equal to 0, the product is not going to equal 0. If a is 2 and b is negative 1/2, well, 2 times negative 1/2 is not going to equal 0. Right? That would multiply to be a negative 1. Okay. If x is 3 and y is 10 and z is 2, 3 times 10 times 2 is not going to equal 0. It's going to be 60. Okay? So if anything ever, it's the definition of 0, multiplication of 0, if any value is 0 in a multiplication, then the product is 0. So that's what this is saying. I have 2 parentheses in this case, 7x minus 9 and x plus 3. If the product is 0, then one of them has to be 0. So what we're going to do is we are going to set each of these equal to 0. So 7x minus 9 equals 0. We'll solve that by adding 9 and dividing by 7. So 9/7 is one answer. The other answer, we're going to take the x plus 3 and we're going to set it equal to 0. So we subtract 3 from both sides, so x equals a negative 3. So the two values in the end are called solutions, or x-intercepts, or they can also be known as just zeros. Okay? They are the values that make the equation 0. Okay? So that is method number 1, solving by factoring. All right, solving by factoring sometimes is the faster method. Sometimes it is not the best method. Just kind of depends on the problem. Depends on how well you can find the factors of a problem. Definitely, if the leading coefficient is a 1, I would use factoring. Okay. Or if the leading coefficient is a smaller number, in this case 7 and 27, when you multiply them, it makes a pretty big number. Okay. But if you can find the factors, it is very easy once you get to this point here where you just set. So again, that is method number 1, solve by factoring. The second method is something called the quadratic formula. Okay, so the quadratic formula, the first step is exactly the same, set it equal to 0. All right, so we already have that here, using the same problem, just in a different method. All right, so this is after I moved the 27 to the other side. You set it equal to 0. We identify a, b, and c. All right, and again, a, b, and c come from the general format of a quadratic. So in this case, a is a positive 7, b is a positive 12, c is a negative 27. We now apply what is called the quadratic formula. And the quadratic formula is all based on the numbers that represent each of the a, b, and c, and it becomes just a formula. Okay? Now, there's not really a nice way to remember this formula, but it does solve any type of problem, whether the problem factors, whether the problem doesn't factor. The breakdown of the quadratic formula does come into context later on in algebra as we go through this. So really there's two parts to this. There's a negative b over a 2a. We're going to look at that here in just a moment. And then there's the b squared minus 4 times a times c part. So what this is going to be a part of the vertex. Okay, so we're going to look at that. All right, it's actually the x-coordinate of the vertex. And then what this part right here is called is something called a discriminant. Ran out of room there. Let me rewrite it a little bit smaller. So, discriminant. All right. And now what the discriminant can do is it can give you some insight into can it factor. So if this discriminant, b squared minus 4ac, so if the discriminant is less than 0, you can't factor it. There's no solution. If the discriminant equals 0, then you're going to have one answer at the end. So like the previous slide, we got two answers. We got negative 3 and we got the 9/7. So what that does, the discriminant tells you that. So if the discriminant is less than 0, then it's impossible. You can't factor it. If the discriminant is 0, you only get one answer at the end. And if the discriminant is greater than 1, you get 2 answers. Okay. Right now, in Algebra 1, that's not going to play a big role, especially with where we're, kind of time constraints. But again, as you get into Algebra 2, you're going to see, these terms again. So just kind of making mention of it so that you're kind of on board with what we're doing. But after you apply the quadratic formula, you solve, you get your 2 values for x, and then the question is done. All right, so let's just erase this part for now. Okay, so if we apply the quadratic formula in this problem, we have x equals a negative of b, so b was 12, so we have negative of 12 plus and minus the square root of 12 to the second power minus 4, and then I put a and c in parentheses. So 4 times 7 times negative 27, all divided by 2 times 7. And now you can do this one step at a time. You could say that negative 12 plus and minus the square root of 12 to the second power is 144, and 4 times 7 is 28. But you can also just type all of the under the square root into a calculator all at one time. So 12 to the second power minus 4 times 7 times negative 27, and that becomes 900 all over 14. So now we continue to solve. All right, and again, they're still equal to x. So now we have negative 12 plus and minus, but now we find what is the square root of 900. So square root of 900 is 30 divided by 14. So we have 2 possible ways to go. So path number 1 is negative 12 plus 30 divided by 14. Path number 2 is negative 12 minus 30 divided by 14. So going the first direction, when we add the 30, that becomes 18 over 14, which does simplify to 9/7, or you could get a decimal value. And the other direction is going to be a negative 42 divided by 14, which simplifies to negative 3. So, same 2 answers we got down here on the other page using factoring. This doesn't involve having to think of any factors. What you have to do is just apply this quadratic formula. Once you apply the quadratic formula, your values at the end, whether you make them decimals, whether you leave them as fractions, it doesn't really matter. If you get something, in this case the 900, we could take the square root of it. Makes the problem a little nicer. If that were, say, the square root of 800, that wouldn't have a perfect square root. In that case, you would just use the decimal value and then continue simplifying it with the fractions. Okay, so 2 methods to solve quadratics. Now, why this is important? Kind of the full piece to this whole puzzle right now is drawing the picture. Okay, again, something that we're going to not dwell on a ton, just due to time constraints. But again, it's just that introducing it to you so that you have seen the application of a quadratic and polynomials here. So when you graph, just like any linear equation, you always look for the constant term. The constant term in our quadratic is the c term. So c was 27, right? But it was negative. Well, that becomes the y-intercept. So you would plot that on the y-axis. So if I go by 2's, negative 27 winds up being right down in here. Okay. We then solve the quadratic, and we got values of negative 3. So again, if I go by 2's, that becomes a point right in here between negative 2 and negative 4. And then 9/7. 9/7 is a little bit greater than a 1, so we're just going to approximate and put that one there. Okay. So again, our C term here was negative 27. 27. Our x-intercepts were negative 3 and 9/7. And then now we have our vertex. So the vertex, by definition, a vertex is the highest or the lowest point. So it's the top of the hill or it's the bottom of the valley. All right, it's the top of, the lowercase n in the little hump in the middle. It's the bottom of a U. Okay? It's the top of a capital A, or it's the bottom of a lower or a capital V. Okay? So that's what a vertex is. All right, a vertex is that one point. So we get that by, again, using a formula. So in our case, it's the negative of b divided by 2 times a. So negative 12 over 14. So negative 12 over 14, we could simplify. That's a negative 6/7. So that's almost at negative 1. So what that means is that right in here, about negative 1, that becomes kind of the line of symmetry. We then take this value and we're going to plug it in. We're going to plug it in for x in our equation. So I would find negative 6/7 as a decimal. So negative 6/7 as a decimal to the second power times 7 plus 12 times negative 6/7 minus 27, which gives us a negative 32.1. So what that means is that negative 32 would be down here, a little bit off my grid, and now we have our graph. We're going to curve through this point. It's going to be a very narrow graph. And then we're going to curve down and we're going to go through the other graph, the other side of the graph. Okay, now I kind of missed my point here. But we have to go starting from the vertex, and we curved through that y-intercept here. And we're going up through the point, the blue point there. Okay, so this just happened to be a problem that was a very, 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 very narrow U. Okay. The A term, which in this case is 7, is greater than 0, so that means it's going to be a U shape. If A happened to be a negative, it would have been an upside down U. Okay, so this is just, again, worrying about where all these numbers and why it's important. This is how we graph a quadratic. We plot the constant, which is C. We use the solving the quadratic method, whether it was factoring, whether it was the quadratic formula. That will give us our x-intercepts. And then the vertex comes from the non-radical part of the quadratic formula, that is the x-coordinate, which tells you kind of where is the line of symmetry. And then when you plug that value into the equation, that'll tell you what the highest or the lowest point is as a y-coordinate. Okay? So the vertex, you actually write it, it's written as an ordered pair. So, this would really be negative 6/7 as the x, negative 32 as the y. Okay? So it is a point. Vertex is a point. Okay? So again, right now our main focus is going to be, can we solve the quadratic? But I just want, again, you aware of where this can be important and why it's necessary. All right, and it all comes to the sketching of the graph. So a couple more examples. So the first one here, if we have x squared plus 5x plus 6. Okay, so again, if we are going to kind of draw the graph as we go, but I want to focus on solving. All right, so the first thing we would do is solve. We're going to set it equal to 0. We would try to factor it. Now this is kind of the easy factoring, because you can say what has a product of 6 that has a sum of 5. And we know that that is 3 and 2, 3 and 2. So 3 times 2 equals 6. 3 plus 2 equals 5. So x plus 3, x plus 2. We use the zero product property. When we set the first x plus 3 equal to 0, we have a solution of x is negative 3. When you set x plus 2 equal to 0, we subtract 2 and we get x equals negative 2. Again, if we are looking into the graph, we would have negative 2 x-intercept, and we would have negative 3 x-intercept. We also have c, and c is the constant. So 6 is our intercept. Since a is a positive 1 in front of x squared, it is going to be a U shape. We could look at the vertex. So negative b is negative 5 divided by 2. So that's negative 2.5. But now we take this value and we would plug it in for x. So we would say negative 2.5 to the second power plus 5 times negative 2.5 plus 6 is a negative 0.25. So what that means is at negative 2.5, which is right here on this line, we go down 0.25, which is barely underneath the x. So we would curve up, and we curve up to the right, going through the y-intercept. Okay. But right now the main focus should be right here. Can we solve? The next example, set equal to 0. If we're going through the solving process, all right, so if you're just going to use the guess and check method this time, so to multiply to get 2x squared has to be a 2x and an x. So now we have to think about values that multiply to be 12. So 1 times 12, probably not going to work to make a 5 in the middle when we check the outer and inner. Maybe it's going to be the 6 and the 2. I would try a 3 and a 4. So try a 3 here and a 4 here. If you looked at the outside, that's 8x, and you look at the inside, that's 3x. So to make a negative 5, this has to be a negative 8. So we need a negative with the 4, and we need a positive with the 3. So now we have our factors. Again, you could have done the same thing from the box method. you would have been looking for a product of negative 24 that would add to make negative 5. Okay? Still would have wound up being an 8 and a 3. Okay. So we would set 2x plus 3 equal to 0. We would take x minus 4 equal to 0. So we would solve by subtract 3. So 2x equals negative 3. We would divide by 2. So you have a negative 3 over 2, or negative 1.5. The other factor, you're just adding 4. So you get a value of 4. Okay. Again, we could have done the same thing using the quadratic formula. We would have said a positive 5 plus or minus the square root of negative 5 to the second power minus 4 times 2 times negative 12. That whole fraction would have had a denominator of 2 times 2. Okay. But since both of these problems did factor, and they didn't have larger numbers, so determining the factors were relatively easier than maybe that first example that I did with the 7 and the 27. Okay. Now, if you were graphing this problem, it would have a negative 12 as the y-intercept. It would have an x-intercept at a positive 4. It would have an x-intercept at negative 1.5. And then we would determine the vertex by doing 5 divided by 4. That would be the x-coordinate, and then we would substitute that in to the equation and solve. Okay? But right now, like I said, we're looking at, can we get to these two solutions? The next example here turns out to be 4x squared plus 81. Okay? Now, right away, that may not factor. Okay? The only way that we factor something that has a plus sign that is a binomial would be a difference of squares, but the plus sign makes it not a difference. So this time, maybe you want to try the quadratic. So a is 4, b is the term with x, which there is none. The pen is not working. So that is a 0, and the c is going to be 81. So what we're going to do here is we're going to say the opposite of b, which is 0, plus and minus the square root of 0 squared minus 4 times 81. And then that is divided by 2 times 4. So 0 plus or minus the square root of negative 1,296 divided by 8. Now, back to that first method of, or first thing that I said when looking at the quadratic. If you get a negative underneath here, this just means that there are no x-intercepts. Which doesn't necessarily mean there's no solution. As we look into a graph, what this would be, since c is 81, so this would be an 81 up here, this would just be a parabola that just doesn't cross the x. Just kind of, it's like a helium-filled balloon. If you took a helium-filled balloon and you tried to throw it, out a window in the second floor, it's probably not going to hit the ground. It's going to curve down to a certain point, and then it's going to float back up. Okay? So it wouldn't hit the ground necessarily. That's all that's happening in this example. But there is no x-intercept. So there is not a solution to that equation where it is going to equal a 0. Okay, so that does happen from time to time. It would not factor, and then the quadratic in this case gave us a value that was not going to provide a solution. The last example that I'm going to look at, I'm actually going to change this just so that we do get something that you have to use the quadratic formula for. All right, so first things first, set it equal to 0, so x squared. Move the 13x over, so you do the opposite. Move the 30 over. to the other side, so you have to do its opposite, which is going to be a plus 30. Now it would be set equal to 0. So I subtracted 13x from the right side to the left, and then I added the 30 from the right side to the left. Now we have a is 1, b is negative 13, and c is 30. So we have our values of a, b, and c. We plug them into the quadratic. The opposite of b is going to be 13, positive this time, plus and minus the square root of negative 13 to the second power minus 4 times a 1 times a 30. We are dividing that by 2 times 1, 2 times a. So now we have our formula, which is going to be 13 plus or minus the square root of negative 13 squared, which is 169, minus 4 times 1 times 30. So we wind up with 49. And then on the bottom, we have 2 times a, which is just 2. Right? So now we have 13. The square root of 49 is going to be a 7. And on the bottom is a 2. So our two solutions, 13 plus 7 is 20 divided by 2. So that is 10. 13 minus 7 is 6 divided by 2, which is 3. So again, we get our solutions to the problem by using the quadratic formula. Now, this problem also could have factored, because two things that would have multiplied to be a 30 that would have added to be 13 would have been 10 and 3. So, two ways could have done the problem. All right. One last example. So we'll say 2x squared minus 5x plus 10. We'll make that 10 a negative, to be honest. All right, so now let's set it equal to 0. So here's our last example that we'll look at. And in this case, a is 2, b is negative 5, and c is going to be negative 10. All right, so using the formula, we're going to say the opposite of b, which is going to be a positive 5, plus and minus the square root of negative 5 to the second power. Now you got to be careful when you do this on a calculator. Make sure you put parentheses, right? Or just remember that anytime you take a square of a negative, it becomes a positive. So that's going to be a 25. Minus 4 times 2 times negative 10. On the bottom, 2 times a, which is 2. So this becomes 5 plus or minus the square root of negative 5 squared, which is 25, minus 4 times 2 times negative 10. So what that winds up being is 105. On the bottom is 4. So now as we're solving this problem, we have the square root of 105. That doesn't work out nicely. All this means is this problem would not have factored. So we have two possibilities. 5 plus the square root of 105 is 10.2 if we round to 1 decimal. Divide by 4. The other option is 5 minus 10.2 divided by 4. So you always solve it once with the positive and once with the negative. So up here at the top, that's going to be 15.2 divided by 4. And the other one is going to be a negative 5.2 divided by 4. So we have two answers. We could get the decimal values by just doing the division. So this one is negative 1.3 down here. And the top one, 15.2 divided by 4, is a 3.8. So my two solutions, those would be your two x-intercepts of 3.8 and negative 1.3. Okay? So again, if you get to a problem like this, and this is where that discriminant, so the discriminant in this case was the 105, or the discriminant was the under the radical part. If that discriminant is a number that you can take the square root of, like the previous example was 49, that just means that the problem could have factored. If it is not a square number, then you cannot factor it. Okay? And then you would have to use the quadratic. Okay? If you were trying to do this by factoring and you made the box, what we would be looking for is two things that multiply to be 2x squared. Down here would be negative 10. The product would be a negative 20x squared that would add to be negative 5. So product of 20 would be 1 and 20. Can't add them or subtract them to make a 5. 2 and 10, you can make a 12 and an 8 when you add and subtract. And then 4 and 5, which add to be 9, they subtract to be 1. There are no factors. So if you try to factor this, it's not working. So the answer is not going to be prime or no solution, because now we're not determining that. We're determining the x-intercepts. Right? So if this happens down here, then you just have to kind of dive right into the quadratic formula, okay? Which isn't something that for right now you're going to need to memorize. It's just, can you apply? Okay, so this is the last little topic that we're covering, being able to solve, and then we're just kind of concluding our lessons here with quadratics and with polynomials. Two ways to solve: factoring and the quadratic.